Good morning. I'm Mr. Harris. I'm here from Mr. Harris's School of Maths, and I'm going to teach you today to do some solving of trig equations. This is a very difficult skill. This is probably level 8 or 9 in the GCSE. Only really tackle this once you've got to grips with trig graphs and how they work. It's one of the final things you would probably prepare for your GCSE, but this skill is still very valuable. I've got my year 10s and they're trying to learn some of these things at the moment. So what we're going to be looking at today is how we can use the graph and our knowledge of the graphs without actually drawing the graph or having a drawing of a graph to solve the problems, and using our calculators as well. So with that in mind, I'll need to reach for my calculator. While I do so, let's get started. Okay, as you can see below in the description, there is a link to a Corbett Maths worksheet, which is a brilliant resource. So what I'm going to do today is I'm talk you through a couple of the questions and then talk you through the first question on there, and then you can go off and get on with it. It's only a short video, maybe 10-15 minutes, but it hopefully will cover everything you need to do. So as you can see on the screen, we have the sort of problem that this is going to be needed to do. Now, in the last video, we saw how we can read this off on the graph by actually drawing across. So we could say sine x equals minus 0.5 actually happens here. And we can read off using a straight line all the places where this happens. And we could, if I line it up properly, we can get a nice straight line and we can see this happens in two places. And it happens at 210 and 330. And we talked also about the lines of symmetry of that. But what if we didn't have the graph? What if the graph sadly goes missing? Well then, there's still a solution to our problem. All we have to do is remember a sketch of the graph. We have to remember and learn what the graph looks like if we sketch it. The sine curve, because we're told that this is sine, the sine curve starts at 0 and goes up, then down, and down, then up, with 180 and 360. What we then do is we take our sine x equals minus 0.5, and instead of reading, we use our calculator and use the sine minus 1 button, which is the shift, then sine. If I shift sine minus 0.5 and then close my brackets and press equals, it tells me the answer is minus 30. What we then do is go, minus 30 you say. That looks awfully like this. So therefore, it will be the same here. Because we know that all these graphs repeat every 360. So we can do 360 minus 30 to get 330 as one of our answers. And if you remember in the drawing, that was one of the answers. The other answer comes from our understanding of a mirror line reflecting this distance over here. So we knew that this was 30 because it told us it was minus 30. We go 30 the other side, plus onto 110, and we get plus onto 180, and we get 210. There are our two solutions. We can put those straight away. But we've already seen those. Mr. Harris knew they were the answers. What about when we don't know the answers? Well, sine x equals minus root 3 over 2. We're going to use the sine to the minus 1 again. So sine to the minus 1, shift sine, minus root 3 over 2 equals, Mr. Harris didn't come out and do the bracket properly, sine to the minus 1 of minus root 3, out of my square root thing, that's why it's not working, root 3 over 2. And then you have to come out of the fraction to close the bracket, and you get 60 degrees. But we draw the sketch of the curve, but this time, if it tells us the first answer is 60, we're going to use a different knowledge of symmetry. The other thing we learned last week was that at 90 is another line of symmetry. We can reflect that across. If that's 60, we need to reflect 60 from 180. So we can do 180 minus 60 is 120 is the other solution. So what we need to do to do this topic, this skill, is understand the sketch of the graph, then understand where the symmetry is. In the cos graph, it's even easier because the cos graph has a big line of symmetry. In the tan graph, it just repeats every 180, which is probably the easiest one to do. And then we check our answers using a calculator by putting them back in. So if I put sine 120, it tells me the answer is √3/2. So it's just checking my understanding. Now, I think that means I may have messed up slightly. But it's because... No, it's not. I haven't messed up. It's because the minus √3/2 will happen at 60. That shouldn't have happened, should it? Mr. Harris must have made a mistake here and not put the minus in the right place. Because we should have minus a √3/2 and we wanted sine to the minus 1 of that. So we want, there we go, and it should have been minus 60. If it should have been minus 60, Mr. Harris probably should have spotted that coming. We're going to rub that out. Where is it minus 60? Well, we don't want that, so let's start the graph again, because this is all good practice. We want to start the graph again, and this is why we check our answers, because we want to spot the mistake that we deliberately make. We sketch it. There's my sine curve. Minus 60. Well, it's going to carry on. There's 60. Okay, so the next one must be 60 away from 360. So it must be 360 minus 60, because you can see it's going to be the same. So it must be 300 is the first solution we've got here. Then we use symmetry again. The symmetry was at 270. So whatever that distance is, which we just said was 60, probably best if I don't shade that in like an area. That distance there is 60. So we want that distance there to be 60 from 180. So we're going to do 180 plus 60 is 240. And there's my two solutions, 300 and 240. We've also got another equation below. It's a sin. So the first thing we're going to do when we see a sin is sketch the curve. I can't emphasize this enough. Knowing how to sketch the curve is worth its weight in gold. Sketch the curve. But this time we've got 8 sin x is 2.5 from 0 to 270. So we're going to carry on. 0 to 270. But we want to do 8 sin x. Now, this is where some thinking about actual algebra comes good. 8x equals 2.5. We would all divide by 8 by this point. So therefore x would be 2.5 divided by 8, which is 0.3125. So this works no differently. Therefore sine x, we divide by 8, sine x equals 0.3125. Now I'm ready to do my minus sign. I can only do it once I've got a single sin. I can't do it with 8 sin. So I get x equals, and I sin to the minus 1 of the answer, and it gives me 18.2 degrees. I'm going to round that to 18 degrees because it's approximately 18 degrees. So we then think about our sketch. If that's 18, we look along and we think about mirror lines and it repeating. So that gap there must be 360. And that gap there must be 360, which is going to be helpful. We've got our 18 degrees, so we can add 360 to that and get 378. So that one's 378. The other one must be a mirror line. That mirrors that. So therefore 18 is 180. Remember the sketch. 180 minus 18 is 162. So we've got 162, and that's got 100 and the 360 jump. So 360 plus 162 is going to be 422. So there's my 4 solutions. The reason for 4 solutions, because it wants the interval 0 to 720. Now let's skip on here. We've got 2 more. So we've just done that one. This one is 6 sin theta equals 5. So sin theta, first of all, is going to be 5 divided by 6. I'm then going to sin to the minus 1. So theta equals sin to the minus 1 of 5 to 6. Make sure you're in degrees mode when you do this. So you get theta equals 56 degrees. Then we sketch. It goes up, down, up, because it's the 360. We mark on the key points, 360, 180, and 540. And as you can see, I've got lessons starting I'm going to have to go to in a second. And I've got 720. And so 0, and we've got the solutions of 56. That 56 is repeated with a mirror line. So if we've got 56, we've got 180 minus 56. So I think it's going to be 56. 180 take away 56 is 124. But then we can see it repeats every 360. So we need another to add another 360 to that. We're going to get 416 and 484. That's 360, 416 and 484 degrees. There you go. There are all your solutions that you need for that interval. So if you have a go in the worksheet, they all look like this. They all work exactly the same way. But if it only goes from 0 to 180, you only use that bit of the curve. So it only goes from 0 to 180, but this will still have two solutions. We can see what they're going to be, but we don't know until our calculator tells us sin to the minus 1 of 0.75 is going to be 70. So theta equals 49 degrees, 48.5 it gives me. 49. So I'm going to do 180 minus 49 for the mirror line. Don't forget the mirror line. So it's going to tell me that it's going to be 131. That's the two angles, and because they're both less than between a 0 and 180, I've got my two answers. So I would write them down, 49 and 131. Don't forget my degree symbol. So have a go at the worksheet. Hopefully that's been helpful. If not, feel free to rewind, or remember, you can always ask questions. If you ask me questions, send them to the email below, put them in the description below the video, and let me know how you get on. Hopefully this little bit short video has been helpful today. 15 minutes, but then 45 more minutes if you go away and do the questions. And that's really the key point. Go away and try these questions, and hopefully they will be useful for you in doing as well as you can in your GCSE, and maybe if you're an A-level student, going on to do well in those as well. I've been Mr. Harris. You haven't. Take care of yourself. Goodbye.